Today we're going to learn about comparing the stability of ions and the sizes of ions based on their numbers of protons and electrons. So first, the stability of ions. Atoms on the periodic table tend to gain or lose electrons. That way they can become stable like the noble gases, having the same number of electrons as a noble gas. So for example, sodium loses an electron and becomes sodium plus, because sodium, if you look at your periodic table, has 11 electrons, so it wants to lose one to be stable like neon that has 10 electrons. So that's why you don't find pieces of sodium metal lying around on the ground, because they'll react to lose an electron to become more stable and turn into Na+, and usually form ionic compounds. So here's a problem. What ion will these atoms form to become more stable? So number one is potassium. So look at your periodic table. It's atomic number 19, so it has 19 electrons. So it's going to lose one to be stable like argon that has 18. It loses one electron, which is a negative charge. Losing a negative charge makes it then have more protons and electrons, so it is a positive charge, or 1 plus. Look at fluorine. How many electrons does fluorine have? It has 9, because that's its atomic number, so it's going to gain 1 to be stable like neon and have 10. When it gains an electron, electrons are negative, so then its charge will be minus, or -1. Look at helium. How many electrons? 2. So it already has a number of a noble gas because it is a noble gas, so it won't gain or lose. Look at calcium. Has 20 electrons, so it's going to lose 2 to be like argon with 18, so it'll be a +2 charge. Look at oxygen. Has 8 electrons, so it'll want to gain 2 to be stable like neon, so it'll be a -2 charge. Look at aluminum. Has 13 electrons, so it'll want to lose 3 to be stable like neon, because neon is closer in number to it than argon is, so it'll be +3. Magnesium with 12, so it'll lose 2 and be +2. And phosphorus with 15, so it'll gain 3 and be -3. Next thing we're going to compare is relative size of ions. To do this, you need to compare both the number of protons and the number of electrons. When an ion has more protons, it becomes smaller, because the extra protons don't make the atom any bigger, because the nucleus is like 10,000 times smaller than the whole atom. So adding a proton is insignificant, but it does have a hefty charge, so it attracts the electrons of the atom more, draws electrons in, makes the atom smaller. When you add electrons, it makes the atom bigger, because electrons are on the outside of an atom. So, for example, which is a bigger atom? S-2 or P-3? So I want to compare both the protons and the electrons. So sulfur, just look at the periodic table for protons. The charge has not changed the number of protons. Charge comes from electron differences. So sulfur has 16, phosphorus has 15 protons. For electrons, if it was neutral, then the charge would be 0. So since sulfur is a 2- charge, that means it has 2 extra electrons. So that would be 18. Since phosphorus has a 3- charge, has 3 extra electrons, that would be 18 also. So because electrons are the same, we'll just look at the number of protons in this example. Sulfur has more protons. More protons makes it smaller, so that means that phosphorus is bigger because it has less protons. One more example, which is a smaller ion, magnesium 1 plus or magnesium 2 plus. So again, we're going to compare two things, protons and electrons. Protons, look on the periodic table. It doesn't matter what the charge is, so both magnesium plus and magnesium 2 plus have 12. For electrons, a positive charge means it has 1 less electron than the neutral atom. 2 plus would be 2 less electrons, that's 11 and 10. Having more electrons makes an atom or ion bigger. So that means that magnesium plus is bigger. That means magnesium 2 plus is smaller because it has less electrons. Hope this helped.